Hello class, what's up? It's Raj here. So today we are discussing about the class 9 science chapter 3 atoms and molecules. So this is notes is very simple, structure and easy to revise class and copy friendly also for the examination out there. So first topic is class, what is the loss of chemical combinations? If you're talking about the loss of chemical combination, so law of conservation of mass. So what do you mean by the law of conservation of mass including out there? So given by Antonio and Lavoisier. Okay, given by Antonio Lavoisier. So mass can be neither be created nor be destroyed. We can know that class mass can be neither be created nor be destroyed. This is the law of conservation of momentum. So equals to total mass of the reactant equals to the total mass of the product. So both are directly proportional to each other. So for example, we're taking the example of carbon and oxygen. When the carbon combines with the oxygen, give rise to the carbon dioxide. So 12 gram of carbon and 32 gram of oxygen. So given rise to the 44 gram. So there is a carbon dioxide is a 44 gram out there. After that, law of definite propositions. Who is given by Louis Braus. So a compound always has the same element in a fixed ratio. We can know that class there is a compound participate in the combination of the reactions and has the same elements in a fixed ratio. For example, H2O. So there is a H, that part is a 1 and O, that is part of 8. 1 is to 8. The simple defined ratio is a 1 is to 8 are there. After that class, Dalton's atomic theory. Main points. Matter is made up of tiny atoms. First of all. Second, atoms can be created or destroyed. Second point. Third, atoms of the same elements are the identical. And number fourth, compounds form in a fixed ratio. We know that class. There is a very important postulate that the Dalton's atomic theory. So there is a main point. The matter is made up of the tiny atom. First of all, there is a small particles including out there, and after that the atoms cannot be created or destroyed. We know that class atoms cannot be created or destroyed. That particular things including out there, and atoms of same elements are identical to each other. So we know that class the compounds form in the Fink's ratio. That's all come under in a Dalton's atomic theory. Next, there is a limitation. So does not explain the isotope. That is a limitation. Yeah, you can say the exceptions are there. So it does not explain the isotopes. Next, atoms, molecules, and ions. If you're talking about the atom is the smallest particle of elements. First of all, if you're talking about the atom is a smallest particle of element and may not exist freely. If may exist freely and not exist freely, that come under in the atoms. But in a case of molecules class, how they are differentiated from each other? 1 second. So switch off the fan for the good quality of sound that I'm telling you right now. So small particles that can exist independently and the source properties of substances including are there that come under in the molecules. If you're talking about the types of molecules, what do you mean by it? The monoatomic, diatomic, triatomic. If you're talking about the monoatomic, that is the helium and neon come under in the monoatomic. If you're talking about the diatomic, S2 and O2 come under in the diatomic. If you're talking about the triatomic, that come the O3 and CO2 that come under in the triatomic. What do you mean by the atomicity? So there is a number of atoms in a molecules that is known as atomicity. For example, O2 that denoted by the 2, O3 that is denoted by the 3, P4 that is also the 4 including out there. So after that, the symbols of elements. If you're talking about the symbol of element, based on English and Latin names including are there. If you're talking about the elements, sodium symbol denoted by the Na, iron that is denoted by the Fe, copper denoted by the Cu, and potassium is denoted by the K. So these all are the symbols of the element and name of element, and these are the symbols chart. Next, ions and valency. If you talk about the ion, the charged particle is also known as ion, and there is a two type of charged particles. First we call the cation and second we call the anion. If you're talking about the cation is the loss of electrons, that is known as cation. If you're talking about the anion, the gain of electron including in the anion. So both are the charged particles, and the ions and valency including are there. How? Example, Na plus NCl minus is including the examples. What do you remember the valency class? Combining capacity of an atom, it including in the valency. So first of all, I telling you class right now, just 1 second. Yeah, so combining capacity of atom that come under in the valency. So these are all including in the one thing out there. After that, the chemical formula, this is the criss-cross rule. What do you mean the criss-cross rule? If you're talking about, there is a right symbols, that is the Al and O come under in the right symbols. If you're talking about the right valency, that is Al3 plus O2 minus is come under the right valency, and criss-cross, that is Al2O3. So if you're talking about what is the valency of Al, that is a plus 3, and what is the valence of oxygen, that is the minus 2. When they combine to each other, then the 2 is going to that places and 3 is going to these places. Though they are intersect to each other, and the combining combination are there. After that, what is the example of it? Compound formula: sodium chloride, that is denoted by the NaCl, calcium oxide, that is denoted by the CEO, okay, and CaO, and aluminum sulfate, that is Al2SO4 whole thrice. So that are come under in the example of it. After that, the mole concept. 1 mole equals to 6.022 into 10 to the power 23 particles. That is known as also the Avogadro number including up there. After that, the important relations. Mole equals to mass divided by molar mass, that come under in the mole. Mole equals to particles divided by Avogadro number. So this has come under the also mole. These are the important relations for the examination or for the numerical solving aptitude. After that, what is the example of it? 1 mole of O equals to 16 gram, and 1 mole of H2O equals to 18 gram. Oof. 1 second. So if we're talking about the molar mass, so sum of atomic masses including are there. For example, CO2 equals to 12 plus 16 into 2. The total combination of that is equal to 44 gram per mole including in CO2. Next, the important formula for the revision. If you're talking about the mole formula, that mole equals to mass divided by molar mass. And the particles formula, particles equals to mole into 6.022 into 10 to the power 23. And the gas volume at a STP, 1 mole equals to 22.4 liter. That's come under in the gas volume. After that, quick revision for the examinations. So mass is conserved in reactions, first of all. Second, the compound has a fixed ratio. Number third, atom is not equals to molecules, and the ion is equals to the charged particles. For example, 1 mole equals to 6.022 into 10 to the power 23, and they use the criss-cross formula. Okay, and example for the exam tips, very important. What we learn, that laws and scientists, okay, formula, the criss-cross, mole calculations, definition, atom, molecules, and ion. So thank you so much class. Please like, subscribe, share my channel how much you can. Jai Hind, Jai Bharat.